Hi friends, today welcome you in your class of or lecture of class 8th mathematics CBSE board lecture number 4 chapter 1 rational number. In previous class or in previous video we have discussed about laws of whole numbers. Two laws of whole numbers. First law we have studied, that is closure, and second is commutative. Before start this class or this video, I would like to request you, please subscribe my channel, like it and share it, and press the bell icon so you will get the notifications of all upcoming videos. And from class 6 to class 10th I have uploaded the videos of maths. So if you want to search other videos of your class, then you have to type my name Mahesh Valande, and you have to type my name Mahesh Valande and your class. Suppose you are in 8th class, then you have to search Mahesh Valande class 8. Or otherwise you want to specific chapter, then you may search, like if you want rational number chapter, so you can search Mahesh Valande rational numbers. So you will get the specific chapter. So now let us start our video. Next law is there, associative law. In associative law we have to take three numbers. These laws are on whole numbers. These laws are defined on whole numbers. So A, B, C should be whole numbers. So it can be written as small a, small b belongs to capital W. Now there should be operations, addition, subtraction, multiplication or division, any one of these operations. And we have to check this associative property whether it is hold for addition or subtraction or multiplication or division. It will hold whenever both the sides are equal. Now, if there is operation of addition, we have to take three elements or three numbers which are whole numbers, and while adding them we have to put two brackets. In first we have to put bracket for A and B, perform addition, and then add the C number, third number, to it. In next operation, put the bracket for B and C, add them and add A in the result. In both the cases, if we are getting the same result, so we can say that the addition of whole numbers is associative. Now let us take one example. Suppose there are three numbers, 2, 3 and 5. 2 plus 3, we have put here bracket for 2 plus 3. 2 plus 3 plus 5. 2 plus 3 is 5, 5 plus 5 is 10. Again, in next step, we have to put bracket for 3 and 5 and add 2 in it. So 3 plus 5, 8, 8 plus 2, 10. The both results are equal. Hence we can say that addition of whole numbers is associative. Now for subtraction, A minus B minus C. Whenever there is a subtraction, associative law or commutative law does not hold for subtraction. Take any of the numbers. Take any of the whole numbers. It will not hold for whole numbers and natural number only, because in subtraction we are getting negative numbers. We will get also negative numbers. And here for associative law we have to take three numbers. One example is there, 2 minus 3 minus 5. So first we put bracket for 2 and 3. Here we put bracket for 3 and 5. If the 2 minus 3 is there, 2 minus 3 is minus 1, again minus 5. Minus 1 minus 5, it will be minus 6. And here, first we have to solve bracket 3 minus 5 is minus 2 and 2 minus in bracket minus 2. So minus into minus plus 2 plus 2, it will 4. It will become 4. 4 is not equal to minus 6. Hence, whenever there is a subtraction, associative law does not hold for subtraction of whole numbers. It will not hold for subtraction of whole numbers. If we are taking integers, then subtraction of integers is associative. That is the example of next. On that example we will discuss in next class. Now multiplication. We have to take three numbers A, B and C. Multiply them by changing the place of brackets. Let us take one example. 2 into 3 in first bracket multiplied by 5. And here 2 into in bracket 3 into 5. Here first perform 2 into 3. 2 into 3 it will 6. 6 into 5 30. 2 into 3 into 5. 3 into 5 15. 15 into 2 13. In both the cases the result is same. Hence we can say that multiplication of whole numbers is associative. Now for division. If division is there, associative law for whole numbers does not hold, because we will take one example here. 20 divided by 5, bracket close, divided by 2. First we have to perform 20 divided by 5. So 5 4 the 20, again 4 divided by 2, so it will be 2. Now bracket is for 5 and 2. First divide 5 by 2, it will 2.5. Again 20 divided by 2.5, so it will 20 divided by, if we have to cancel this point, so we have to put 1 0 after 20 in numerator, so the decimal point of denominator will be cancelled. So 200 divided by 25 will be there. 21 1 the 21, 21 8 the 200. The answer is 8. Result is 8. And here the result is 2. So both the results are different. Hence, division of whole numbers is not associative. We can say that division of whole numbers is not associative. Next law is there, distributive law. In distributive law, there are two laws. Distribution law of multiplication over addition and distribution law of multiplication over subtraction. While over addition we put sign of plus in bracket, and while subtraction we put the sign of minus in bracket. If we multiply with A to the bracket, and in bracket there are two terms, and in between there is a sign of plus, then we have to multiply with A to both these numbers, and we have to put plus sign in between them. So A into B plus there will be A into C. Let us take one example. Suppose 3 plus 4 multiplied by 7. We can take it as, if 7 is there, 7 is there in left hand side. So 7 into 3 plus 7 into 4. We can write it as like this. So next, distribution law of multiplication or subtraction. Now A into, in bracket there is a subtraction, B minus C. Then multiply by with A to both these numbers and put minus sign in between them. So A into B minus A into C. Now if we interchange the places of these two numbers, bracket and A. Bracket is first and then we put A. Then also the distribution lies same. We have to multiply with A to both B and C. So B into A plus C into A. Now B minus C into A. Then B into A minus C into A. Next properties, so next lies there existence of additive identity. Existence of additive identity. Now, in previous class we have discussed about identity element. What is identity element? Identity element is the element who gives the identity to any number. It means if we perform the operation with that number, if we perform the operation of identity element with given number, the result is equal to the given number. The identity element does not changes the identity of that element or does not changes the number. So addition is there, operation is of addition. So we have to perform addition. Then which number is there? When adding with A, the result is A, that is 0. So 0 is additive identity. If A is a whole number and we are adding 0 to a whole number, we will get whole number itself. Let us take one example. Suppose 5 is there. If we add 5 plus 0, then there will be 5, the result. So 0 is the additive identity which does not changes the identity of the given element after adding it. So it is additive identity. Next, there is multiplicative identity. Now, multiplicative identity, we have to perform operation of multiplication. If we multiply any whole number, A is a whole number. Small a belongs to capital W means A is a whole number. So if we multiply A with any number or any number 1, any number, it means not any number, it is a fixed number 1. If we multiply any whole number with 1, we will get that number result itself. So A into 1 will be A. So 1 is the multiplicative identity, because after multiplying with 1 to any number, 1 does not changes the identity of that element. So 1 is multiplicative identity. So today's lecture is now going to stop. We will see you in your next class. So thank you very much. Bye bye.